All right, Screencast 3, we're continuing on with the decision process for a perfectly competitive firm. Last time we talked about whether the firm should stay in business or shut down and what price it should charge. This time we're moving to the third question, what quantity should the firm produce? Well, in terms of this question, on one level, the answer is pretty easy. Produce whatever quantity will maximize your profit. After all, that's what businesses are going after, right? On another level, this may be the most complicated question. Now, what we're going to see is that there's actually two approaches to figuring out for a perfectly competitive firm what quantity is going to maximize their profits. They're called the total revenue and total cost approach. And in this approach, if we have total revenue and total cost numbers for different quantities, we can figure out which quantity would result in the greatest profit. There's also something called the marginal revenue and marginal cost approach. And in that approach, if we have marginal revenue and marginal cost numbers, we can figure out the profit maximizing quantity. We'll start with the total revenue and total cost approach. Now you'll remember that total revenue and total cost, if we have them both, we can figure out economic profit. Economic profit is equal to total revenue, all the money coming in, minus total costs, all the money going out. So let's say we had some data for a perfectly competitive firm. Let's assume that the price they're charging is $131, the same price we've been working with. And let's say we had total fixed cost and total variable cost data for that firm. Let's say the total fixed costs are equal to $100, again, maybe the cost of a lease. If they sold 0 units, their fixed cost would be $100. No variable costs, because you don't need any workers or any kind of variable materials to produce 0 units. The total cost would be $100. Total revenue would be price times quantity, and here the quantity is 0, so that would be 0. If you take total revenue of 0 and subtract total cost of 100, you will get your profit, in this case, negative $100. In other words, if this firm produces nothing, or if it just shuts down, it's going to lose $100. If it sold 1 unit, its total fixed costs don't change. It'll incur some variable costs now. You can see what the total cost and total revenue numbers would look like, and you can see what the profit would look like. 2 units, 3 units, all the way through 10 units. You might want to pause the video just to make sure you understand what each of these columns are doing and how we're getting these profit numbers in the final column. Well, if you stare at the table long enough, you might see what the profit maximizing quantity is. Can you see it? Yes, you can. If you look at the table closely, or if you just go down that profit column, you'll notice that profit maximization is happening at 9 units. The greatest economic profit of $299 is happening right here, where total revenue is that and total cost is that. Now, it's a little easier to see what's going on if we look at this graphically. So we're going to graph out total revenue and total cost. Here's what total revenue would look like. It keeps going up by $131. In perfect competition, it's basically a straight line upwards. Every unit it sells is another $131. Price times quantity. If we graphed out that total cost column, it would look something like this. Now remember, economic profit is equal to total revenue minus total cost. So this yellow area that you see, you can think of as economic profit. At any quantity, let's say a quantity of 6, it's the difference between total revenue, which is the green line, and total cost, which is the orange line. Total revenue minus total cost equals profit. So this vertical distance right here would be the economic profit if you were to produce 6 units. Now, maximum economic profit happens where we see the biggest spread between total revenue and total cost, the biggest difference between the two. Here in this graph, as it was in the table, that's happening at 9 units. So if you see a graph like this, what you're looking for is the biggest spread between the total revenue line and the total cost line. Now, kind of as a side note, you might notice a couple other things about this graph. Specifically, these 2 points. Right down here and right up here. We call those break-even points because at those points you'll notice that total revenue and total cost are exactly equal. In other words, those would be points where economic profit is 0. Or another way of saying that, those would be quantities that you might produce where you'd only earn a normal profit, no economic profit. All right, so that's the total revenue and total cost approach. Most commonly on the AP exam, you're shown a graph like this and asked to find the profit maximizing quantity. And again, you're looking for that biggest spread. Alternatively, on the AP exam, you might see a question that looks like this. So you might want to pause the video for a second and see if you can figure out the answer. Pause, unpause, answer. All right, again, greatest economic profit happens at the biggest spread between total revenue and total cost. To figure out this answer, you would take the total revenue number for each quantity and subtract from it the total cost number. At an output of 0, profit would be negative 50. At an output of 1, profit would be 40 minus 74, and etc. And in this table, the greatest profit would happen at 5 units, 200 minus 172. All right, total revenue, total cost approach. Let's move on to the marginal revenue, marginal cost approach. Vastly more important than the prior approach for reasons that we're going to see, because this approach is the approach we're going to use for all 4 market models. We're going to learn a rule here that may be the most important rule in all of microeconomics. Well, to understand the rule, you have to go back to kind of the beginning of the course and think about the rule for doing anything. Remember that whether you're trying to decide how many hours to spend with your girlfriend, how much time you should spend studying, how many pieces of candy to eat, we had a rule for that. The rule was go up to the point where the marginal benefit is equal to the marginal cost. Now, putting those in terms that a business can understand, for a business, marginal benefit is the marginal revenue, right? Marginal revenue is how much additional money you're getting for selling an additional unit. And to a business, the benefits are profits, money. So we can equate conceptually marginal revenue with marginal benefit. Marginal cost for a business is simply marginal cost, how much more it costs to produce each unit. So thinking about it conceptually that way, a business should keep on producing units, keep on adding to the quantity, as long as the marginal revenue, the money coming in from selling that additional unit, is at least as much as what it costs to produce that additional unit, marginal cost. And ideally, a business would produce up to the point where those two are equal. And by doing that, it would produce every single unit where it could make a profit, where it would bring in more money than it would cost to produce. So this is a unit by unit approach. A business should keep producing additional units until the marginal revenue of the last unit produced is equal to the marginal cost of that unit. Or another way of saying that, keep on producing, keep on adding to your quantity until this is true. The marginal revenue is greater than or equal to the marginal cost. This is that most important rule that I was talking about, and I'm going to call it the profit maximizing rule. If you're a business and you want to maximize your profit and you're thinking about what quantity to produce, you can use this rule. And by the way, monopolists can use it, monopolistic competitors can use it, all 4 market models can use it. You can use this rule to figure out what your profit maximizing quantity is. All right, again, so let's go back to some data. Now, this time, instead of showing you total data, I'm going to show you per unit data. This is where the average fixed cost, average variable cost, average total cost, marginal cost numbers come in. Because remember, from the last unit, that's per unit data, not total data. So again, let's stay with that price of $131, and let's keep on assuming that fixed costs are $100. What I want you to focus on are the marginal cost and marginal revenue columns. I've included the black columns there just to see show you where these numbers come from. But I want you to think about the blue, light blue and the red columns. Let's imagine that we're producing the first unit. For this first unit, the marginal cost is $90. What that means is that producing that 1 unit is going to cost you $90 more than producing 0 units. Marginal revenue is $131. So if you produce this first unit, $131 more are going to go into your cash register, and it's only going to cost you $90 to get that $131. In other words, that's a good unit to produce. More money is going to come in than is going to leave if you produce that unit. What about the second unit? Marginal cost, $80. Marginal revenue is $131. Whether or not to produce that unit is kind of like answering this question. Would you like a situation, would you take a deal where I handed you $131 if you handed me $80? That's a good deal. That business should take that deal. That business should produce that unit. Same with the third unit. Third unit is going to cost $70 more to produce than 2 units did, and that third unit is going to bring in another $131. By the way, notice these marginal revenue numbers, and remember why they don't change. They're equal to price, which is $131. Well, look at the units unit by unit. Think about whether you would produce that fourth unit. There's the marginal cost, there's the marginal revenue. Keep on going down until you can see where we maximize our profits. And you won't be surprised to see that it's exactly where we were maximizing the profits before, at 9 units. This ninth unit makes sense to produce because it's costing you $130 additional dollars to produce it, but you're going to get $131 back. The 10th unit doesn't make any sense because it would cost you $150 to produce it, but you're only going to get $131 if you do. You're going to make a loss on that 10th unit. So again, you want to produce every unit where the marginal revenue is greater than or equal to the marginal costs. And that happens up until 9 units. That 10th unit doesn't make any sense. We get the same profit maximizing result as last time using the total revenue, total cost approach. Let's see what that looks like graphically. To do that, we're going to go back to our graphs for perfect competition. Remember, we have the industry on the left-hand side with supply and demand. We have one individual firm on the right-hand side, one apple farmer. And so far, we've drawn one line and we've called it Mr. Dark. It's equal to marginal revenue, it's equal to demand, it's equal to average revenue, it's equal to price. So we're going to focus on this graph and we're going to blow it up a little bit just so we can look a bit closer at it. But as I do that, I don't want you to forget about the graph on the left-hand side. That graph still exists. That's where the price is coming from in the graph on the right-hand side. Alright, so blowing it up, it would look like this. Now the approach says go up to the point where marginal revenue equals marginal cost. And we already have marginal revenue in the graph. It's that line, right, equal to price at $131. So to use this approach, what we have to do is incorporate the marginal cost curve into this graph. Do you remember what marginal cost looks like? Maybe? Little hint? Remember, we spent most of the last unit trying to describe what these cost curves were and what they look like and why they look the way they did. And a lot of the reason we did that was so that we can bring these cost curves into these next market model graphs to understand how firms operate. That black line, remember, is marginal cost. It goes down and then it goes up. Why does it go up? Law of diminishing marginal returns. Excellent. All right. So let's throw that marginal cost curve into our graph. There it is, that Nike swoosh looking cost curve. Now in terms of profit maximization, think about the rule but apply it graphically now. We're going to produce every single unit where the marginal revenue is greater than or equal to the marginal cost. So starting on the left-hand side, marginal revenue is here, marginal cost is here. Notice that we would produce every single one of these units down here. For every one, the blue line is greater than the pink line. Marginal revenue greater than marginal cost. Next unit, marginal revenue is greater than marginal cost. That's true for all of these units up until the two curves meet. Where the two curves meet, if we follow this rule, is going to determine the profit maximizing quantity. If we go beyond this quantity, let's say we go to this next unit, the 10th one, notice that the marginal cost is greater than the marginal revenue. The money leaving as a result of producing that unit would be greater than the money coming in. So to apply the marginal revenue equals marginal cost rule, the profit maximizing rule, what we're always going to be looking for in these graphs is the intersection of the marginal revenue curve and the marginal cost curve. And that's going to give us our profit maximizing quantity. All right, that's it for this screencast. See you next time.